These are just more ways to evaluate the limits. Two of them that you need to just know, I guess I can read that. They're highlighted in purple here. Guys, you have to just, I hate saying memorize them, but you do need to just, anytime you see limit as x approaches 0, sine of x over x, you got to know that's 1. Only when it approaches 0, yes. Okay? So those two commit to memory, okay? Looks like the graph. Yeah. All right. Then we're going to use some of those. We are still evaluating, yes. Just, they've gotten slightly trickier. We can't just plug it straight in. Man. I know, that was enjoyable. Okay. So guys, when you start, you should always approach it with, okay, let's try plugging it in first. But if you get divided by 0, then you know you have to do something else. Okay? Yes.
Does 1 minus sine x over x also equal 0?
Nope.
But like, no, never mind.
It's basically not the same. No. It looks like it. Okay. We're going to start with number 2, just because we don't need all of these examples, so we'll do this one first. So guys, if I tried to just plug 3 in, do you see how there's a problem? Yeah. Okay. So one of your options is to try to factor. See if you can factor and cancel that out. You know how there's a hole in a graph? That's what you're trying to do. So limit as x approaches 3. What does that numerator factor into? Okay. Over x minus 3. Okay, those go away, right? Gone. Now could you plug it in? And what do you get? And you're done with number 2. So that's not really that much harder, is it? Okay. Factoring is fun.
Factoring is satisfied. It's like cross off 2 fractions.
Yeah, it's like the instant gratification. All right. Let's do 3 because I want to make sure we remember how to do this kind of factoring. Oh, this factoring's not so fun. All right. Everyone sees how we can't just plug it in, right? Okay. So that numerator, it factors into x minus 1, because that's the cubed root of each of those. X squared. So plus, and then you're just multiplying the 2, so what's 1 times x? Okay. Plus 1 over x minus 1.
So what's the formula?
Alright, so if it's a cubed minus b cubed, it's a minus b times a squared plus ab plus b squared. Okay. But then do we see x minus 1's go away? Can I plug it in then? Yes. And what do I get? Okay. 1 plus 1 plus 1. I think we can handle that. Maybe. It's tricky today. Friday. All right. Any issues on 3? Okay. Definitely make sure you know how to factor cubes. Okay, that's a thing that will show up. We don't actually have any quizzes in this unit, so you only have your test. We will use, we've had quizzes before, so we'll use some of the quiz questions as like whiteboard practice, stuff like that in class, but you won't actually have to take a quiz. Okay? All right, number 4. Okay, can I plug the 4 in? No, because you get 0 in the denominator. All right, trickier when we see a square root. Do you guys know the conjugates? Yes? Okay, so I'm going to multiply numerator and denominator by the square root of x plus 2. Okay. Do not jump ahead here because I'm going to save you time. Do not multiply out your numerator. leave it as x minus 4 times the square root of x plus 2. What you do want to multiply out is your denominator. You see how these are the two that are conjugate to each other? Those are the two I want to multiply out. So what is square root of x times square root of x? X. And then it ends up being minus 4. Yes. You guys see it? Do we see how it's minus 4, or did I lose anybody on that?
I see.
Plus root 2, or I'm sorry, plus 2 root x minus 2 root x gone. Okay. And then, yes, we can get rid of our x minus 4. Do you see how if you multiplied that numerator, you'd have a big old mess that you couldn't cross anything out? Okay. Then, plug it in. What do we get? Okay. So far, so good. Let's do, I want to see what's on the back here. I know I need to do 6, but. Alright. Yes, that's going to require you to use, like, perhaps this guy. Okay. Alright, so let's look at 6. Can't plug 0 in, right? Okay. The limit as x approaches 0. Let's think about how we can rewrite tangent. What is tangent? Okay, so we've got sine of x over cosine of x. And then this is just algebra stuff, guys. It's divided by x. Isn't that the same as times 1 over x? Yeah, okay. So, limit as x approaches 0. I'm going to say of sine of x over x times 1 over cosine of x. Is that equivalent? Do you have to write the limit every time? Yeah. Guys, proper notation is to write that limit as x approaches 0 in each step, okay?
We'll need points here.
Not a lot, but some. Okay. Now we can look at this as two individual pieces. You're basically thinking of the limit as x approaches 0 of sine of x over x times the limit as x approaches 0 of 1 over cosine of x. Okay? Sorry, let me move this up a little for you guys. Am I losing anybody in here with like rewriting this like this?
So I'm going to put something sine of x over cosine of x.
I didn't multiply by anything. I just, these two switched places. This is multiplication, I can do that. It's like 3 times 2, 2 times 3, something different. So I just switched the cosine and the x. So because I know this, I know sine of x over x. Right? And then this I can figure out because I can actually plug 0 in. So what is the limit as x approaches 0 of sine of x over x? 1 times, oops, that is not a fun. All right, plug 0 in. What is the cosine of 0? 1. So we have 1 times 1.
It was 1.
1.
You're good.
Yes. Okay. Good work. All right, questions so far? So that's the ways you would have to use those first two that I said you need to memorize. Okay, like you would use them in the substitution and the simplification. All right? Okay. Don't peek on the next page here. Let's see. Okay. All right, let's try 7 and 8. So 7 here. I'm asking you the limit as x approaches 3, and then I give you this piecewise function. The piecewise function, that's basically telling you like 3 from the right and 3 from the left. Okay? And remember, like piecewise functions, if they equal each other, the limit existed or it was continuous, that sort of thing. Okay, so let's plug 3 into each of these. So if I plug 3 into the first part, what do I get? 9. If I plug 3 into the second part, what do I get? 14. Okay. So guys, what that means is that one of your graphs is at 9 and the other piece of your graph is up at 14. If you're walking on those, are they running into each other? No. So what are you going to tell me? Yes. So what are you going to tell me about your limit? Yeah, it does not exist. That's it for that one, okay? Yes, because it only asks you as x approaches 3.
Oh.
Okay? So, does not exist. Alright. Okay, so number 8, we are back to a graph here. So the limit as x approaches 2 of f plus g of x. So what you can do is look at the two individually and then add them together. So what is the limit as x approaches 2 for my f function? 1 plus, what is the limit of g of x as x approaches 2? And 1 plus 3 equals 4. Okay? Yeah, not bad. It looks, I mean, those graphs look kind of scary, right? It's not. That's it. Okay? This unit is really not bad, guys. All right. You try number 9. Did you just use your calculator? Oh. For what? 4 minus 4 or 2 times 4?
Just 4 minus 0. I don't know if this person's calculator.
Okay. You got 0, right?
Yeah.
Okay.
So you're saying determine exists as
Oh.
yeah. Oh,
Yeah, it's 0. All right, guys, did you get 0 for both? So does the limit exist? Yes, okay. And if I asked you what it was, you would tell me 0. 0. All right. Don't be this. Okay. Yeah, guys, you see that like 1993 AB2, all the weird.
Yeah.
That means the Calc AB exam from 1993. So, there are multiple versions of it, so that's my guess. All right, guys, so let's look at it. So if f of x equals 2x squared plus 1, then we got to figure out the limit. So let's do some substituting here. So we are looking at the limit as x approaches 0. Well, what could I replace f of x with? 2x squared plus 1 minus, what is f of 0 going to be? 1, right? It's just plugging 0 in over there. Over x squared. Okay. So we can't just plug it in because we'd have 0 in the denominator, right? So let's do some simplifying. I've got 2x squared in the numerator. That's all that's left, right? Over x squared. So what happens there? X squareds go away. So I'm left with just a constant of 2. So what does that make my limit? 2. So C, what's the right answer?
So you don't plug in.
There's no x left to plug it into. Well, then you'd be dividing by 0.
When would $8 exist? Or what about 960?
not what's happening here. Yeah, because the limit is actually 2. The function value doesn't exist at that point. Like if you tried to find y there, there'd be a hole. But there's still a limit, yeah. If it ended up being like a graph with an asymptote. Yeah. Like if you were left with something where you could plug it in, but I don't remember which ones I usually do. I don't want to have you do 11. Alright guys, let's try 12. We'll do this one together. Alright, so f of x equals natural log of x when x is between 0 and 2, and it equals x squared natural log of x when x is between 2 and 4. And I'm trying to find the limit as x approaches 2. What do I do with that 2 then, since it's a piecewise? Plug it into both, right? So for the first one, I get natural log of 2. And for the second one, I get 4 natural log of 2. Okay, you don't have to know the exact values of those. You just need to know, are they the same or not? No, it's some number and then 4 times some number. So they're not going to be equivalent. So what does that tell us about the limit? Does not exist, okay? Question? Okay. Oh yeah, it could be, you're right. Yes. No doubter. All right. I realized I should have just erased everything from the beginning, guys, but I didn't. Do you want to try this one, or do you want me to help?
Just do it right 0.
Try it. Cool. Okay, you guys try.
Oh, it's not.
I'll tell you that it's not E. If it exists.
We have now 25% chance.
All right, guys. Let me start going through it for you. Everyone understands we can't just plug it in, right? Okay. I'm actually not going to factor the numerator just because I can see what's going to happen in the denominator. Do you guys see how it's difference of squares in the denominator? Yeah? Okay. So then I can get rid of that. So what's in your numerator even though it canceled out? 1. Okay, good. So I'm going to plug in a, and I would have 1 over a squared plus a squared, which is 1 over 2a squared. Okay? Okay, and those are tricky, guys. I mean, these are calculus questions, so you're not in calculus, so. You're doing great. Anybody questions? I know we went quickly today, but are we okay? We'll see. All right, so homework, we are going to do homework for both 9.2 and 9.3, but not a lot. So homework 9.2 looks like this in your packet. It says homework 9.2 at the top. Let's do multiples of 3 on that. So that is 12 questions. But those were the ones, plug it in, or you might have to simplify it a little, but nothing major. Then you got to flip a couple pages. You're obviously already to the notes 9.3. Homework 9.3, it's just one-sided. I am going to do it all. I'm just debating even or odd what I want. Let's do odd. That'd be no problem. There you go.
Yeah, there's really 3 problems.
For multiples of 27, no, there wouldn't.
There are multiple.